This is our PLC logic coding that we got from Do More Designer. It's a free software that allows you to simulate a PLC. Since we're not able to actually simulate it with our PLC until we have it plugged in, we had decided to find another means to simulate this PLC working when we didn't have access to it. So we found this software. Anyways, I'll get to the code before I start running it. So how we have it set up is that when we start the code, uh, we kind of want it to be able to check for errors just in case if, something bad happens, like, um, say the jig slips off and the measurements get off. We don't want that motor to continuously spin for no reason, going to no value whatsoever and lead to issues where it may start, stripping, or it even if the motors wasn't mounted properly, if it would cause the motor itself to kind of whip the other side and cause damage to, like, mower or even the operator themselves. So we wanted to incorporate those errors. Sadly, I can only incorporate an alignment error because it's not really possible to simulate that on the simulating software, as I would have to be able to find a way to incorporate some measure of a slip that would occur and then basically cause the process to stop and pick back up after you've pretty much fixed the error at hand. So for this, we have an alignment error where we would determine some preset value to show that, because you're not going to have you're not going to have a value that's lower than what it can physically actually reach. So we want to have a starting initializing value to prevent that issue with say it falls off and the motor just starts spinning and it's not changing the value at all. It just keeps spinning until it's pretty much more or less stripped the bolt or gotten out of control. So my initial plan was I was going to have the second error put in place with the no error, so that way it would all run in the same sort of setup. But because I can't simulate it, that's why it says no error here, as opposed to just having no error as the alignment. So right now we are in an error state because, well, we're not in an error state yet. I'll just press that button. Now you can see that we're in an error state where there's no signal going to alignment because we are currently in an error state because we are at D0. Since we can't simulate the analog value by getting analog values, we have to simulate it through digital outputs to kind of showcase it all working. So I'll just basically go through how I have it simulating itself. So I have it structured with a timer block and a math operator. I was going to have it just pulsate by, like, increment by 1 each time, but that was going to take forever. And honestly, I don't think, I think you get the point after it's reached the value and then pretty much stopped. So I just had a math operator do an addition of 15, and it pulses that up until it reaches this prescaler right here to, like, 500, greater than or equal to 500. Notably, that's obviously arbitrary, and the way we have it set up, it's not going to be this way. I do plan on basically putting essentially, like, subroutines and stuff like that is listed. I don't think it kind of shows it on, well, I think it does show it, but essentially we would want to condense this into small processes, so that way it's easier to kind of, like, look at the individual process and have it pulsate that way. I looked into some videos on how to kind of do that, and I would like to incorporate that in this design as we go forward, as it would make it easier to troubleshoot issues in the long run, and for Kubota to look back at and make additions or subtractions wherever they see fit. once we turn this project over. Um, but essentially, it'll reach 500. It will basically declare front motor calibrated, which will then stop this process from occurring again, because we don't want it to constantly pulse 15 after the fact, because it kind of defeats the purpose. So right after and basically to pulsate it, we had to use T0, and once it declares it done, it pulses the math operator. Anyways, that's not the big part of the project. I pretty much repeated the process for the second side, where it would approach that 500 and then it'll just cut off. And then for the last, I just wanted to show it being done. Notably, right after this process, I would want to capture the height data from both of the blades and then kind of showcase, if it, like how accurate it is to reaching our goal of maintaining that distance and that angle that we want to achieve for the front and the rear side of the mower. Well, for the blade tips. So I'll set these values, and then it'll kind of simulate the whole process. Because it's at 260, we're no longer in an error state. So it's essentially, as you see here on the status, it goes up to 500. And then once that happens, you'll notice that the front motor calibration turns on. And then we start on the back motor. And because it's a free software, I should note that it is very buggy. Right after it finishes the first process, it likes to automatically jump to that 500 for that second digital output. Not entirely sure. There's nothing wrong with my coding. That's just how it kind of works, I guess. Still got some bugs. After all, it's a free software, so it's definitely going to have some quirks in it. But essentially, as you see here, it's pretty much done. The one thing I didn't incorporate was the back motor. That is supposed to tell you, like, that is supposed to say off as opposed to on, but I had neglected to put essentially the normally closed right here, so that's my bad. But actually, I think that's how that works. Oh well. Anyways, this is essentially how it all work. It would capture the height, and then we'll capture that height, put it into a CSV file that constantly updates as we do like many runs to kind of get ourselves that CPK value that we want to achieve with Kubota, which I believe is